Welcome to the course Depreciation, Alternate Investment and Profitability Analysis. We are continuing with module 2, which is alternative investment. In the present lecture, I will be dealing a method which is called rate of return method. Basically, this is not a pure method, this can be applied on any method. We have seen that all our calculations are based on time value of money, that means rate of return, and that is why if the rate of return changes, the decision of selection also changes. This is what we are exactly going to see in this lecture. The rate of return method. In the present worth method or annual cost method, we compared either the present worth or the annual cost of two alternative investments at a predetermined rate of return. What happens if the rate of return varies? Whether the decision remains unchanged or it changes with the rate of return. This is what we are going to investigate in this lecture, and you will see that when rate of return changes, the decision will also change. Through examples, this question has been answered in the rate of return method, and how the decision changes when rate of return changes is demonstrated. Now, we will be using some formulas. The present value is being converted into annuity A. So, this is the formula A is equal to P I 1 minus 1 plus I to the power minus n. And if you are changing F to A, the formula is A is equal to F into I 1 plus I to the power n minus 1, and the present value of perpetuity is given by PV is equal to PA divided by I. Now, let us see through examples how the rate of return affects the decision. So, this is a formula, this is also the formula. Now, objective 1, given the capital investment, 0 salvage value, same estimated life spans, compare two different investments based on annual cost method for different values of minimum acceptable rate of return. So, we will be using annual cost method to demonstrate this is rate of return method. Now, let us see the example 1. Data for two machines A and B are given below. Plot how the annual cost of both machines A and B vary with variation in minimum acceptable rate of return, that is MARR, from 6 to 30%. Now, we have the following data with us: machine A, machine B, capital investment 10,000, this is 8,000, and the useful life is 10 years, salvage value is equal to 0, operating cost 3,000 and 3,500. this is the value, and we will see how the annual cost varies. If I vary the value of I from 6% to 30% and then plot it and see that what percentage, that means at what value of I the decision will change. Now, let us compute. Our formula will be a P I 1 minus 1 plus I to the power minus n, because we will be converting the present worth, this is the present worth, to annuity. So, for MARR equal to 6% or is 0.06. Now, annual cost of capital recovery for machine A is equal to the cost 10,000 into this formula 0.06 divided by 1 minus 1 plus 0.06 minus 10. This comes out to be rupees 1358.68. So, total annual cost of machine A is equal to 1358.68 plus this value, which is the operating cost per year 3000. This comes out to be rupees 4358.68. So, at 6% I have this value. So, 0 point is a 6%, this is machine A, this is machine B. The annual cost is 4358.68. Now, if it compute it for B machine at MARR is equal to 6%. So, annual cost will be cost of capital recovery for machine B will be, the cost is 8,000. We have this formula. Now, 0.6 1 minus 1 plus 0.06 to the power minus 10. This comes out to be rupees 1086.94. So, total annual cost for machine B is equal to 1086.94 plus this value 3500, which comes to be 4586.94. This is 4586.94. Now, what we have to do? We have to repeat this many a times, this computation, to find out the values. So, let us do this for 10%. So, this becomes 0.1. So, for machine A, annual cost of capital recovery for A is equal to 10,000 into 0.1 divided by 1 minus 1.1 minus 10 comes out to be 1627.45, and so total annual cost for machine A is equal to 1627.45 plus 3000. It comes out to be rupees 4627.45. So, this is 10%, 4627.45. Now, the same thing for B machine. For B machine, this will be 8000, and this value is 1301.96. This is B machine, and this is 1301.96 plus 3500 comes out to be 4801.96. So, this is 4801.96. Now, you can go for 15%. This is 15%. This is 15. This is A. This is 15. This is 15. This is 10. This comes out to be 1992.52. This is A. This is 1992.52 plus 3000 comes to be 4992.52. So, this is 4992.52. Now, if you go for B, this is 8000. This comes out to be 1594.02. This is 1594.02 plus 3500 comes out to be 5094.02. So, this is 5094.02. Now, similarly, we have to compute up to 30%. Let me see whether I can give you the values. So, this is 20%, the value is 5385.33 23 and this is 5408.18 and 30%, this is 6234.63, this is 6087.71. Now, what we see here, this is the table and this is the graph which shows. Now, here we see the A value is less than the B value here, but for 30% this is more than the B value here. That means the crossing of decision takes place somewhere in between this. Now, is there a method to calculate? Answer is yes. Two machines will have equal annual cost. We will find that two machines will have equal annual cost at interest rate of 21.346%. Now, how to calculate this? Here from the table we have seen that the annual cost of machine A becomes higher than machine B after 20% MARR. Thus, both the machines will have same annual cost between 20% and 30%. So, if I define delta 1 is annual cost of B for 20% MARR minus annual cost of A for 20% MARR, then it becomes 5385.23 minus 5408.18. So, it becomes minus 22.85. Now, delta annual cost of B for 30% MARR minus annual cost of A for 30% MARR B 5 4. Sorry, this has to be reversed. This has to be reversed. This minus this is B minus A. So, 5408 minus 5385.23 is equal to 22.85. Now, this is equal to 6087.74 71 minus 6234.63 comes out to 146.92. Let at MARR value of x, the annual cost of both machines are same. Okay. So, thus at x, if I call this delta 3, this is 0. That means delta T 3 is annual cost of machine B at x MARR minus annual cost of machine A at x MARR. Now, I can write down x minus 0.2 divided by 0.3 minus 0.2 is equal to delta 3 minus delta 1 delta 2 minus delta 1, or x is equal to 0.2 plus delta 3 minus delta 1 divided by delta 2 minus delta 1 into 0.1. This gives a value 0.2 plus minus 22.85 divided by in bracket 146.92 minus 22.85 into 0.1. This gives 0.21346 is 21.346%. MARR. So, in this way we can find out the value. So, up to 20% A will be selected, or I should say up to 21.346% A or B, A will be selected, and after that B will be selected. The plot for this MARR are also given at the side of the table. Let us summarize the whole lecture. In this lecture we saw the rate of return method. Basically, the rate of return method is not a method in actual sense. It can be applied on any method of alternative investment. We have seen that all our methods of alternative investments are based on time value of money, that means based on the rate of interest. So, the decision is also based on rate of interest, and we have seen that rate of interest fluctuates a lot. So, as it is based on rate of interest, the decisions are also based on interest. So, to know how the decision will change based on rate of interest, this method rate of return can be utilized. So, we can speculate that what will be the rate of return after 5 years or after 10 years, and we can see the scenario that what will happen, whether our decision which I am taking today will be valid after 10 years or not. For this we have taken a numerical. We have seen that after 21.346% interest rate, the decision is changing. So, thank you.